This is Nils Delta Kilo 8 Oscar Kilo. In this video I would like to show you some basics on how to work with Winradio's ExcaliburPRO. After installation of the software, you will see an icon on the desktop. Double-click it and the receiver will come into life. The window at the bottom shows the whole spectrum of this receiver from 0 to 30 MHz or even up to 50 MHz. You can switch between both in the Options menu. For this video, I would like to concentrate on shortwave. The upper left window shows a part of the spectrum. Its maximum bandwidth is defined by the so-called DDC bandwidth of the digital down converter, or DDC. All you need to know right now is that's the maximum bandwidth you can record and play. Right to this, you see a snippet of the left window. It is centered on the actual receiving frequency and shows the bandwidth of the demodulator. Next, we want to look at each window in greater detail. Let's start with that of the DDC bandwidth.
Second and third sets 6-4. The defending champion Greta Ahn is also out after being defeated by the German substitute.
With a mouse, you easily can magnify this window. I tuned the receiver to a station in the 31-meter broadcast band. To get a smooth view of this spectrum, I will choose an averaging time of half a second. There are two main views onto a frequency range. One is the spectrum, the other is the so-called waterfall. The spectrum shows the current distribution of power versus frequency. With amplitude modulation, you will see the more or less steady carrier and the current modulation. With the waterfall, the window also shows the distribution of power versus frequency, but in another format where the power is color-coded. You can change the scale of this color coding due to the scenario of noise and signal level of the wanted stations. The waterfall gives perfect information on the bandwidth of each signal, and you can easily see stations which otherwise may be almost wholly covered by noise or a sideband of another station. For now, let's stay a bit with the waterfall diagram. You can change the colors to some other palettes. If you are colorblinded, other colors may give you better contrast and information. "20 kHz is the smallest DDC bandwidth. If you choose a broader one, you have a broader view. With it, two other things are directly coupled. The so-called resolution bandwidth, RBW, and the color of the waterfall. The resolution bandwidth depends on the DDC bandwidth. The maximum resolution is down to 1 Hz. It can be achieved at small DDC bandwidth up to 32 kHz. The higher the DDC bandwidth, the broader the resolution bandwidth. At 4 MHz DDC bandwidth, we eventually will get a smallest resolution bandwidth of 150 Hz. You need a small resolution bandwidth to see details of a signal. Let's take a teletype station as example. Here we see it with a resolution of 1 Hz. This clearly separates its two signals, mark and space. Now I go for a resolution of only 980 Hz. Their mark and space are not separated anymore. Instead, you see the occupation of the whole channel. Each window is provided with zooming buttons, zoom in and zoom out. With a wider DDC bandwidth, they provide some further detail. In this case, the snippet is smaller than the DDC bandwidth. With a slider, you can go to any part within the DDC bandwidth you want. The picture shows the full 100 seconds of the waterfall. This will help in further monitoring documentation. On the wideband display in the bottom, there are two valuable extras. With this display set to spectrum, you can change the minimum level. Normally, it should be adjusted to the noise floor, so you won't miss any signal or peak. Switched to waterfall, you can change the speed of the waterfall in 10 steps. The highest speed of 10 will give a high time resolution, and the whole picture will be 99 seconds long. The lowest speed of 1 will present you with a picture of all activities within up to nearly 1000 seconds, or roughly 16 minutes, at a lower time resolution. Up to now I had concentrated on two of the windows. The spectrum of the third, above right, can be switched between RF and audio. With audio, you exactly see the spectrum of what you are listening to. In the right window, you will see some other data. For the shortwave listener, most important are the lower 4 lines. There you can read the quality of amplitude modulated transmitters like broadcast stations. The first line measures the error of the transmitting frequency. To get reliable results, you have first to warm up your receiver for half an hour or so. Then you should calibrate your receiver against the ultra-stable source, like the 10 MHz output of a GPS-locked oscillator. If you don't have one at hand, second best resolution is to calibrate it against a time signal station like WWV on 10, 15 or 20 MHz. Tune into the nominal frequency of this station. The calibration window will show the offset between the original signal and Excalibur's oscillator. Just click Calibrate to Peak. That's all. The last 3 lines will give exact results only with a 1 kHz test tone being transmitted. This is transmitted from some broadcasters prior the normal program starts. The end? Beware, that's only a small part of what you can do with your ExcaliburPRO by Winradio. Look out for the other videos. See you, Nils, Delta Kilo 8 Oscar Kilo.